Hi everyone, it's Mrs. Meekings. Mrs. Drew has asked me if I can explain the maths answers for the rapid reasoning for this week. So I'm going to do a video each day using a different way to present the answers to your rapid reasoning. We all know in class the best way to actually learn whether we're right and also learn what we should have done if we were wrong is to listen to explanations. And I know you're all great at explaining, but unfortunately you've just got me today, but we'll try and see if we can work in getting some other people explaining as well later on in the week. So I'm looking at day one, so Monday's work, and we're going to look at each question in turn. First question, we need to match the decimal fractions to their fraction equivalents. Now, whenever you see something like this, you need to look and think, right, are this some I know? Let's do those ones first. And hopefully everybody is shouting at me that 1/4 equals 0.25. Hopefully you all know that, and you all know that it's 25% as well. So I can match that one. What else can I see? I can see some tenths there. So I can see 6/10. And I can also see 6/10 on the right hand side because I've got a 6 in the tenths column, so I can match there. Right, what else can I turn into tenths? You've probably spotted it before me. I can turn 30 hundredths into tenths. Let's look at how I can do that using my knowledge of equivalent fractions. I know that if I want to make an equivalent fraction, I need to do exactly the same to the numerator and the denominator. So if I divide the numerator by 10, I'm going to get 3. And if I divide the denominator by 10, I'm going to get 10. So I should have 3/10. And I can see that on the right-hand side, a 3 in the tenths column matches to 3/10. Now, this is one that some of you might already know the conversion for, but there is another one here that we can turn into tenths. Let's have a look at 1/5. So I'm going to do the same to the numerator and to the denominator. So looking at the denominator, I need to double that to make tenths. So I'm going to double the 1, that's the numerator as well, to make 2/10. And there's 2/10 on the right hand side. Now, quite often with questions like this, you can think, oh, well, I've got one left, so it must be the last one. But let's check that, because it's not always a good idea to just say, oh, it must be the right one. Let's check what we know about that. I've got 72 hundredths. So if I look on the right hand side, I can see a 72, that's a good sign. And I can see in the hundredths column, it's got a 2. So 72 hundredths, the same as 2 hundredths and 7/10. So that finishes that question for me. And for the next question, we're looking at temperature, and it looks like we're looking at negative numbers as well. The temperature scale shows the average temperature in a city. Look at the arrow. What is the average temperature in winter? Now, I always nag my maths group, and I'm sure the other teachers do this too. If you see a scale, don't just guess what the scale's going up in. Check it out. Now, I'm thinking this scale looks like it's going up in ones. So let's count to just check. I'm going to count on from 0, 1, 2, 3, 4, 5, and I've ended on 5, which is marked. So it must be going up in ones. Now, because I'm looking at the other side of the 0, I'm looking at a negative temperature. I'm not going to make you count with me, but if you do count, you can see that there are 6 spaces. So for each space is worth 1, each interval is 1, so it's -6 degrees. Hopefully that was the easy part of this question, because then that leads on to the next part. The average temperature in summer is 23 degrees higher than winter. What is the average temperature in summer? So I'm going to use an empty number line for this. I love an empty number line. Lots of people know that. And I'm going to mark on my number line 0. And I'm also going to mark -6 because I need that to answer the question. Because what I need to do is find out what -6 add 23 is, because we're going to increase the temperature from winter to find the summer temperature. So I'm going to do some jumps on my number line. First of all, I'm going to jump to 0. So I needed to jump 6 to add 6 to -6 to make the 0. So now I've got to add the rest of the 23. I've used 6 of the 23. So I need to find out how many of the 23 I've got left. Now I could do a separate calculation to work that out, but I know that 23 take away 6 is 17. So 6 add 17 must be 23. So again, it doesn't matter if it's to scale because it's an empty number line, it's just to help me work it out. I'm going to add 17 from that 0. So the temperature in the summer, or the average temperature, is 17 degrees C. And they've got the degrees C in there, so I just need to put 17 in. I'm just going to double check that. So it says the temperature is 23 degrees higher than winter. I know winter is -6. I'm looking at that. I can see I've added 6 and I've added 17, which is 23 altogether. So my summer average is 17 degrees. Looking at question 3, let's place these lengths in order, starting with the longest. We've got some interesting ones there, because we've got some things that you probably wouldn't always measure in centimetres. I don't think you do 310,000 centimetres. Somebody would say there's a better unit to measure that in. Which order shall I put these in? Sometimes it's worth looking at them to see if I can convert them all to ones that are already used twice. Got centimetres used twice, and I don't want to use those. I'm going to go with the middle one. I'm going to change everything to meters. Now, some of you might be able to do these a pair at a time and order them about, but what I've decided to do to make sure I get this right is convert them all to meters. So I've got 3.5 meters there already, and I'm going to look at all of the other ones and turn them into meters. So let's have a think about the equivalencies I know for measurements and length. I know that 1 kilometre is 1,000 metres. So if I know that 1 kilometre is 1,000 metres, I can say that 3 kilometres is 3,000 metres. So the one at the bottom is 3,000 metres. So I can see already that's a lot bigger than 3.5 metres. What else could I use? What other facts do I know? 1 metre is 100 centimetres, and there's lots of ways that we remember that. I'm always waving a metre stick at my group and they go, oh yeah, it's 100 centimetres, so we multiply or divide by 100. We all know that the word cent means 100, so if we think about per cent, it means per 100. Some units of currency have it. The euros, you would have 100 cents to a euro, 100 cents to a dollar as well. So let's have a look at my ones I can use for centimetres. So I'm going to change centimetres into metres. Because there are 100 centimetres in 1 metre, the centimetres ones I'm going to need to divide by 100. Oh, I don't want to do that 310,000 centimetres yet, so I'll start with the other one. I'm going to put a decimal point in there because it will help me, because to divide by 100, I know I can move all the digits 2 places to the right. So my 3 moves from the hundreds column into the ones. My 4 moves from the tens column and it goes 2 places along, so it becomes the tenths. So 340 centimetres is 3.4 metres. Now, I'm often saying this to the children that I teach, but does that make sense to me? Well, I know that 300 centimetres is 3 metres, so 300 and something centimetres is going to be 3 point something metres. So I'm happy with that one. Right, my other centimetre one, I need to divide by 100 again. Actually, it's not as difficult as I thought because I can just move the digits along. So my 3 goes from the 100,000s into the thousands. My 1 goes from the 10,000s into the hundreds, and then I need my zeros for placeholders. Yes, I know some of you will just take the 2 zeros off if you're dividing by 100, and that's fine because there's no decimal points and you should have the same answer. So that's 3,100 metres. Right, I've got millimetres left, so I need to think about how do I convert millimetres to metres. Now, millimetres to metres, there are 1,000 millimetres in 1 metre. We know the prefix milli means thousand, like milliliter, millimetre. So let's have a look at what I've got. Right, I've got to divide by 1,000 because I'm going from the smaller unit to the larger one. So 30,000 millimetres. Let's divide that by 1,000. To divide by 1,000, yep, I'm moving everything 3 places to the right. So I've moved my 3 from the 10,000s into the tens, and I don't need to move anything else. I just need to put that placeholder in. So if I divide 30,000 by 1,000, I end up with 30, so that's 30 metres. Right, my next one, I can see already 320 millimetres. If I'm dividing that by 1,000, it's going to go into the decimal places, so I'm going to put a decimal point in. Oh, I'll put lots of decimal places in there. So 320 divided by 1,000, I'm going to move everything 3 places to the right. So my 3 moves from the 100th 3 places, and it ends up in the tenths column, and my 2 moves from the tens and it ends up in the hundredths column, because if you count you can see it's moved 3 places along, and obviously I'm going to have to put a 0 in when I do my answer there to show that I've got no whole meters. Right, bit of a long-winded explanation. Some of you probably thought, I know that, but I'm doing this so that everybody who is perhaps struggling a bit with this can see how to do these. So I've got them all in meters. So going back to the question, I need to put the longest first. Shout out to Victor here. Victor, sometimes you don't read this, do you? You might have put them in order, but you might have put them in ascending order, starting with the smallest, but we want the longest, so we're putting them in descending order. So looking down them, I need to remember to write what they've given, not my meters equivalent. So which one is the largest? It's 3,100 meters. So the one that's going to go first is 310,000 centimeters. I'm going to tick that one off to show that I've used it. Right, the kilometre one wasn't far off that, was it? It's 3,000 metres, so 3 kilometres is next. Little tick there as well. What have I got left? Right, they've only got ones. That one's only got decimal places, so it must be 30 metres, which is 30,000 millimetres. And then going down, I've got two that are very close here, but 3.5 metres is just slightly more than 3.4 metres, which is 340 centimetres on their list. And the last one, 320 millimetres, we worked out was 0.32 metres. So that's the answers to today's work, but I thought I'd give you some other things to think about as well. There's lots of disadvantages to not being at school, but there are also some advantages to home learning. And one of the things I was thinking about was home learning really makes it a lot more of an opportunity to be able to think about real life maths, because you're at home and you can think about things around you that are real life. So one of my little challenges to you that I want you to see if you can do and share on Twitter with us on our Year 6 Twitter page is think about those answers to question 3. And can you think about what they mean in real life? So I've picked 3 of them down the left-hand side that I'm going to think about. 3 kilometres. Now, this is an important one at the moment if you're thinking about your daily exercise. 3 kilometres. The average person, I would say, walks at about 10 minutes for 1 kilometre. So if you're walking 3 kilometres, that'd be about half an hour daily exercise. So if you're out and about with your parents, you might want to think about your daily exercise, and maybe if somebody's got a way of recording it, either a tracker like a Fitbit or an app on their mobile phone, see whether 3 kilometres really is 30 minutes. What do you think to my estimate? So I'm going to look at 3 kilometres, and this is one that brings back a little memory for me. If you come to running club, this is the picture from my Fitbit when we did our running club run to Rushden Lakes. And if you look at the black spot there, that is the school. And the white spot is when we first arrived at Rushden Lakes, and that was just about 3 kilometres walking from the school down through the Greenway to Rushden Lakes. And in fact, we ran it, didn't we? So that's 3 kilometres. So that's what 3 kilometres means in real life. And when you're doing your walk, you might be able to think about that. So my next one, I was thinking about 3.5 metres. Now I was trying to estimate this, and I was thinking, is that about the length of a minibus? But then I thought, no, that's a bit more. And I thought it might be the length of my car. So another use of IT here, I had a look on the internet to see what the length of my car was. I wish I'd got a meter stick and I could measure it, but I haven't got one at home. A mini one is 3.6 meters long. So here's my car. That's about 3.5 meters. And if we think about the conversions, that's also similar to the 340 centimeters, isn't it? Just a bit longer there. That's my car when the AA came to visit it earlier this week. And the last one I've picked at the moment to look at is 320 millimeters. So I knew that that was 0.32 meters because I worked it out before. And I also know it's 32 centimeters. So I was thinking, right, let's have a look around my house, see if I can find something that's about 32 centimeters. But one of the other things I didn't bring home with me was a ruler. So I thought, I know that a piece of A4 paper is about 30 centimeters. In fact, it's 297 millimeters. So it's 29.7 centimeters. So I thought that's about 30 centimeters. Let's have a look and see what I can find. So I think this spoon is quite a good estimate for 32 centimeters. So some challenges for if you've got some time on your hands and you want to think about maths a bit more in real life. Could you find some of those measurements that we had in question 3 and find them at home? The other one you could have thought about was 30 meters. So what do you think 30 meters looks like? Maybe think about the school, what 30 meters would look like. If you've got any pictures or if you've got any answers you want to share those with us on Twitter. Now, some of you might be struggling with some of these activities that we're setting. If you still want a bit more work on this, then we can highly recommend going to BBC Bite Size. I'm going to copy some links when I tweet this and when I put this on Facebook. I'm going to copy these links. One of them is the link to the Key Stage 2 fractions and percentages work. And when you go on there, you'll see there's lots of activities, including actually how to simplify fractions. So you'll look at examples like those fractions that I changed into equivalent fractions. And there's some really good examples there showing bar models, showing real life as well. And you might have spotted the word football down there as well. There's a Gary Lineker challenge that you can do on there. So have a go at that, particularly if you need a bit more practice on fractions. And talking about BBC Bite Size, you might want to look at the Year 6 daily lessons that they've got on there. And in fact, today's lesson is the lesson for simplifying fractions. So if you click on the Year 6 work, Year 6 maths for the 4th of May, there's lots of activities that will help you with finding equivalent fractions and understanding that. And I also noticed when I went through there that the 22nd of April was negative numbers. So if you need a bit more work on there, you can have a look at what the BBC are offering. And we recommend looking at those if you're struggling with any of your work.